Mr. Abbott, and I'd like to help you again with another boring activity explanation for Earth science. This one is our tidal range and lunar phases activity. If you look at the front, sorry for how it's shaded, but this is showing you two different maps of the Bay of Fundy, which is located in Nova Scotia, Canada. Specifically, we're looking at Horton Bluff. Now, in Nova Scotia, the Bay of Fundy is this sort of funnel-shaped bay where the water from the Atlantic Ocean comes in, and because the bay gets very narrow and it becomes more shallow and funnel-shaped, as the water comes in, the tide gets higher and higher and higher, and this is showing you that, all the way here towards the north end, you can get a tidal, change between high tide and low tide up to 15 meters or almost 50 feet. Now, the exact data that you're looking at is for Horton Bluff, and Horton Bluff is right here on this map, which is at the far end. So the Bay of Fundy in Nova Scotia, Canada has one of the, most incredible tidal ranges exhibited anywhere on the planet. Now, when we flip this over, you'll see, let me use this one, you'll see on the back of the lab you get a data table. It tells you that this is for April 2003. April has 30 days, so when you look at the data table, it goes from day 1 to day 30. It's giving you two measurements, the height of high tide. It tells you that this is measured in meters, okay, and then the height at low tide. So they're giving you high tide data, low tide data. The lunar phase percentage, or the percent illumination, is shown here. Okay, it goes from 0 to 100%. So 0 was the new moon, 100% is the full moon. Honestly, right here, between 47 and 54%, this would be the first quarter. Okay, and then down here, when you have 50% on this day, this would be your third quarter phase. Now, they give you two other points that are important in terms of considering tides. Apogee would be when the moon is most distant or farthest from the Earth. Okay, the moon's orbit is elliptical, so it gets slightly closer and slightly farther away. And down here you have perigee. Now, for the activity, we're going to start by drawing two lines. We're going to be plotting the data right here. So you're plotting in the one line, which is going to be a line for high tide. So you're going to plot a line for day versus high tide height, plot the 30 points and then connect them. And then you're going to plot a secondary line for the day versus the low tide height. So I'd like to look at the data, set up the graph with you, and then we'll discuss what your graphs should look like. Here's your graph paper. Obviously, one thing that you should be putting up here is you should be putting a title. We know that this is Horton Bluff. We know that it's Nova Scotia. We know that it was also taken for April 2003. So my title has to be descriptive. So this might be an appropriate title, might be tidal data for Horton Bluff. Okay, now you may not know where Horton Bluff is, so this is Horton Bluff, which is in the Bay of Fundy. Sometimes that's spelled with an I, honestly. So tidal data for Horton Bluff, Bay of Fundy, Nova Scotia, which is in Canada, and this data specifically is for the month of April 2003. Now, the horizontal axis, okay, the bottom, this is where your independent variable goes. So this is date, and this is for the date. These are all April 2003. You're not starting at 0 because there's no April 0. There's 30 days, and we have like 32 boxes going across. So the most appropriate scale would be to go by ones. If you really need to write every day, I would suggest alternating the length of the lines. Okay, you could also count 7, 8, 9, 10. You don't have to necessarily write each number. 11, 12, 13, 14, so 15. So you're going to continue numbering that, and your scale should all the way go all the way across from, April 1st to April 30th. All right, now on the y-axis. The y-axis is always going to have our dependent variable. Okay, you'll notice that this is water depth, and the water depth can be a positive or even a negative number. Okay, the mean water level is given at 7.5, so that should sort of be in the middle, but your high tide values are going to be above this, and your low tide values are below it. But I'm going to turn this sideways, and over here I'm going to say depth of water. You always have a label, and for this one, the unit, this was measured in meters. Honestly, later I'll convert the meters to centimeters, which is one of the good things that you can do. Now, I'm not going to sit here and plot every point, but I will make a template. So make sure you plot your points accurately when you do this, because I'm going to have a transparent overlay, and to check your graph, your points should hit my points. Just to show you a few, for the first day, day 1, the high tide was at 12.5. Okay, day 2, it increased slightly to 12.8, so I'm going to estimate it as 12.8 there, and then by day 3, the tide height went to 13.0. All right, you can clearly see my points. Even when I draw my line, you should be able to see my points. Your points have to hit my points. Now, your low tide graph. Okay, I'm going to go down to the bottom. You're going to be plotting a second line. Okay, you have to do all 30 points. I'm not going to show you plotting 60 points, but for the low tide graph, on day 1, the low tide was at 2, which would be that point. By day 2, it got a little bit lower. It was 1.8, so I plot 1.8. Day 3, it went up again. It went to 1.9. That's a little bit slightly closer to 2. Day 4, it went to 2. So now you need to plot all of your points. Okay, once you do that, honestly, you should get a graph that looks something like this. So this is my completely drawn graph for the 60 points. You'll notice the 2 lines. One of the things that I'm going to do, just to make this a little bit easier for you to visualize, after you've plotted the points, I connected them with a smooth curve. I'm going to look at this, and I'm going to connect these points with a highlighter. So the yellow line that I'm plotting up here, it says label it high tide. So if I'm going to label a line, I'm going to draw an arrow, and I'm going to label these high tides, and maybe I'll even make it look fancy by highlighting my label. Now, on the bottom, you got low tide. The tides are definitely caused by the gravitational pull of the moon, and then they can be modified a little bit by the gravitational pull of the sun, and that's really part of what we're investigating with this data. So I'm just highlighting this so it's a little bit easier for you to see in the video. And when you look at this, this lower line is going to represent what you recorded for low tide. Okay, I'll sort of color that in so you can see that the blue represents the low and the yellow represents the high. obviously the level for high tide and low tide is varying. You'll see there are a couple of points when the tides are really far apart. So right around here, the 17th or the 18th, there was an extremely high tide and an extremely low tide. Over here, you'll see that you had a lower high tide and a higher low tide. And there seems to be 2 points where you've got a lower difference between them. Okay, the term that we're going to use to describe that is the change in tidal range. So the range is the maximum minus the minimum, and clearly, this is a cyclic relationship. The tides are going up and down, but sometimes you get a much larger tidal range, and other times you're going to record a smaller tidal range. But that's what your graph should look like for the activity when you're done plotting everything out. Make sure that your scales, that both scales are numbered and labeled appropriately, and you have a descriptive title on the top. Now,